So the two major topics in human capital are, one is schooling and the other training. So schooling means like you guys going to school, like a formal school, like a high school, college, those kind of things. And training is after schooling. So when you get a job after you graduate, then you will usually go through some job training. Okay, not only once, but quite often actually. So these two, schooling and training, similar but different. Okay? So these two are the major topics of human capital. And I think we discussed this in the last class. So what is human capital? What we mean by that? Actually, human capital is a term that is used to be to distinguish from physical capital. So physical capital, it just means that when from the firm's point of view, this includes usually like machines, right? And let's say land, right? Buildings. So these are physical capital that firms use for production. And the other we call, actually what we say is a labor input, right? So we usually say the labor plus capital makes, production, okay? So the human capital, so physical capital is just what we call the capital usually. The human capital is about the labor, okay? So when you think of labor input, okay, what's the labor input? Okay, what involves labor input? One, obviously that it takes time, right? So workers spend time, right? When you get a job, you go to your office or whatever the site that you are supposed to work, and then you will spend 8 hours, 9 hours, 10 hours a day in that place. So you spend time on it. What do you do during the time? You do work, right? And what does work involve? I mean, the work involves using your skills and knowledges, right? It's not just time. You don't sit around and doing nothing, right? You do something, and then doing something requires certain sets of abilities and skills. Those set of abilities and skills we call human capital. Okay? So what does employer expects from their workers? Okay? Obviously, they expect them to spend time doing their work, but not only that, that's probably a secondary thing, right? The most important thing is that the sets of skills and abilities that this worker brings to their work. Okay? That's what the workers are actually looking for. So, the labor input, so I would say that labor input involves, let's say, time, obviously, and skills and abilities, right? And we call these skills and abilities human capital. And so like a physical capital, why do we call it capital? Because these abilities and skills must be accumulated like a physical capital. You have to buy, right? You have to invest, okay, to accumulate your physical capital, like to buy a machine, right? You have to spend your money, okay, and accumulate it. Like a human capital, like those physical capital, human capital also these workers, okay, spend their time, okay, and doing certain things and to acquire it. So these investments usually happen through education and training. Okay, and I think I discussed the formal and informal. So what you're doing is formal education. Informal education could be something like asking to your fellow students. Okay, if you have questions, those are in a way the informal education. Okay, formal training is that if you get a job, then you may go through, usually you will go through a certain classroom teaching process, like a school, going to school. Like you attend a class and you learn something. Also, the informal training involves usually like asking your coworkers, asking your supervisors. Okay, those are also type of training. In our class, we usually think about only the formal types of education and training. Again, investment in human capital, so like a physical capital, human capital should be accumulated through investment. So investment usually means that you pay something right now and you get back the return in the future. That's investment. So human capital is the same thing. You spend your time and money to acquire this. Okay. Right now, actually, you don't have much use for your human capital, for your knowledge. Okay. You don't use it. You don't use it to make money out of it. But in the future, you will use it to make money out of it. Okay. So that's like investments, like a physical investment. You spend your money to buy machines, for example, the farms. And then later, the farms will use the machine to produce things and sell it and make money out of it. Same thing. For you guys, you spend your time and money, and you spend your 4 years, okay, or more than 4 years in university, and then you will get back the return from the investments later. And money, the direct costs like tuitions, foregone earnings are the money that you give up by attending this class. Okay, like you may go out to work, and then you probably earn, I don't know, 1.5 million. One per month usually, I guess, okay, and that's what you are, giving up. So we call them foregone earnings. Okay, so and then a certain set of inborn characteristics are quite important. In this case, we call the human capital set of abilities and skills. So there is a distinction between abilities and skills when labor economists use these two terms. Skills are the knowledges and the like skills that you can acquire through education or training. Learning how to drive, for example, right? Learning how to use computers. Okay, learning how to use a specific type of machines. Those you need the time and your effort to acquire these skills. Okay? And ability, when the labor economists say abilities are something that you cannot acquire. Abilities are what you are born with. Okay? So it's like abilities will affect on how you get your skills. Okay? If you have very good abilities, okay, for example, like let's say you are very smart, okay, and then you will probably find it easier to, let's say, learn second language. Some people have very good, in a way, they have very good inborn abilities to acquire, to learn the languages. Some people are pretty good at it, okay, and these people will find it much easier to learn languages, okay, and these type of foundation that people born with, we call them abilities. Okay? It can be like intellectual abilities. It can be physical abilities. In some industries, physical abilities are quite important. Okay, you are very strong. Your body is very strong, and that can be quite important. Okay, let's say to acquire a certain set of skills. Let's say you want to become a martial arts. Okay, you want to be like a specialist in martial arts. Obviously, that having stronger body and probably the bigger body is quite important, right? But you cannot acquire it. Okay, even if you try very, very hard, you cannot grow much, at your age, at my age. I will shrink at some point. Okay, so we call them abilities. Okay, so there are differences when you say abilities and skills. So these set of inborn characteristics that includes ability, also that personality. Okay, personality. When you talk about it in human capital investment, like patience is quite important. How patient you are. Obviously, investment means that you delay, okay, you delay the time to get the return out of your investment. So if you are an impatient person, right? So you want to get the result right away. So these people will find it very difficult to wait, let's say 4 years, 5 years, 6 years to get your return from your investment. If you're very patient, probably you will find it easier to do that. Okay? Those kind of personalities are quite important in terms of human capital investment. Ability, I talked about family background also. The family background, like how rich your family is. Okay? So some people born with a rich family, usually they can probably find much easier to finance their university education. Okay? But if your family is poor, then you will find it much difficult to finance your education. You probably have to work yourself, or you have to find some scholarships and other source of funding for your education. That can be quite difficult. It will affect, obviously, their human capital investment decisions. Okay? So these things will be considered when we talk about the human capital investment. So these inborn characteristics affect decisions and investment in human capital. In a sense, life is unfair in that sense, So what you're born with will affect, okay, your human capital investment decisions. Then it will affect later your skill levels, okay? Then these skill levels later will affect how much you earn at the end, okay? So that, the chain of events, then people say that life is unfair, okay? Because people born with the equal ability, equal personality, equal background, right? So people will find these kind of things will have very strong effects on the final outcome of their life. And that's the research shows actually quite strongly those kind of links between the inborn characteristics and outcome in the life. Okay. So we just overall looked at what we mean by human capital, and as I said, that human capital can be acquired mostly through two major channels. One is schooling, and the other training. So today we will go through the theory of schooling. Okay, and then theory of schooling have two major models. One is human capital model, and the other we call it the signaling model. And then these two models explain how the schooling is associated with earnings, but with very different sets of assumptions and interpretations. First, we will go through the human capital model, and then we will move on to signaling model, and then we compare them later. Okay? So human capital model. Human capital, before doing it, let's see some interesting statistics of Korean population, human capital in the Korean population. This shows the educational attainment of Korean population 2010. So this is from the 2010 census. Okay, so this shows basically the population statistic of Korean population. We have census every 5 years, so this is the most recent data. And as you can see that high school, up to high school, it's about a little less than 60%. Okay. And then around about 50%. So we have about 50% people who have high school or lower, and we have about 50% people who have more than high school education. That's actually very high percentage. And for men, which is this percentage of higher educated individuals, much bigger than the women. Okay? For women, it's about 40%. For men, it's probably a little more than 50%. Okay? So there is a difference, gender difference in their education level. This is a very interesting research topic, why the women and men have different investment patterns in human capital. Okay? I think if you look at the younger population, probably there is no much difference. But these differences usually, mostly come from the older generations. Okay. So as you can see that individuals who have no education whatsoever, is women, is actually significantly higher than men. Okay. Mostly very old generation. Okay, now second statistics, this shows that I just added today. And this shows, just to show the recent statistics, college educated among the labor force. Okay? So like you guys, colleges or higher, college plus a graduate school. And 15 years ago, year 2000, it was around 17%. Okay? Now, it's almost 30%. Okay? So in 15 years, okay, these percentages actually almost doubled. Okay? It's close to double. Okay? So now it's 3 out of 10 people in the labor force are college educated. It was only half of them in 15 years ago. So Korean labor force has become very highly educated every year, as you can see. And now actually we are debating that we are too much educated. Okay. But that's another thing. But anyway, what it shows that Koreans do spend a lot of time and money in educating themselves. Okay. So this is very high percentage. And actually the recent statistics shows that about 70%, more than 70% of high school graduates do go to colleges, okay, including vocational college. Okay. So that is very high percentage, 70%, more than 70%. Okay, now let's see how the education is associated with labor force statistics. Okay, first thing is LFPR by education and sex. Okay, what you see is that these blue ones are men and the red ones are women. Okay, and what you can see is that obviously that usually more education is associated with higher labor force participation. Okay? So people who are more educated are likely to work more. Okay? So as you can see, doctoral, master is it's a university degree for women more than 60%. For men, about 90% of them are working. Okay? If you go to, let's say, middle school, okay, there is a small difference, but it's smaller. Okay? So usually we see that more educated people are more active in the labor market. Okay? That is very common observation in most countries. How about unemployment rate? Okay. In general, that more educated people are less likely to be unemployed. Okay. But it's not clear in this case because Korea's unemployment rate is pretty low, so it's difficult to see much difference. Okay. But as you can see, for example, people who are only primary educated, okay, very high percentage of unemployment, none, very high. Okay, and similar in these areas. Okay, for women are different. Okay, because the thing is that these low education group do not participate in labor force much. Okay, so it tends to press down the unemployment rate but for more educated people are more likely to be in labor force. So in that sense, they are more likely to be unemployed. Because to be in the labor force, you should either employed or unemployed. Okay? So their labor force participation is different. So for women's case, it's a bit different. But anyway, in Korea's case, because the percentage itself is very low, so it's difficult to see the difference. But if you look at the US data, For example, like if you go to page 237 in the textbook, it shows the labor market characteristics by education group 2010. In this case, actually, the 2010 labor market in the US was pretty bad one because 2008 global financial crisis. So in that market, the unemployment rate is very high. So if you look at the gender, for men's case, unemployment rate less than high school, 18%. High school graduates, 14%. Some college, 10%. College graduates, 5%. So as you can see that unemployment rate goes down as education level increases. Okay? So if you have a college degree, then unemployment rate is only 5% in 2010. But if you have, let's say, high school degree only, it's 14%. So it's almost 3 times, okay, as likely unemployed. And for women's case, it's pretty much the same. 15% for less than high school, 10% for high school graduates, 8% for some college, and 4% for college graduates. Okay? So if you compare like high school graduates and college graduates, and high school graduates are at least twice, okay, twice as likely unemployed as the college graduates. Okay? So in the US case, for example, you can see the clear pattern that unemployment decreases as education level increases. In Korea, I mean, because their unemployment rate is pretty high, so you can see the pattern. In this case, we are not. So actually, during that time, they say that education is the best insurance during recessions. Okay, because as you can see that there is a clear difference. Like if you have college, like your unemployment rate is 4 or 5%. Okay, high school only, your unemployment rate is like 10, 14%. So the education is the best protection, okay, during the recession times. So as you can see, the human capital or education is very strongly related with the labor market performance. That's why the labor economists pay attention to human capital. And the last chart I want to show is the linkage between human capital and education and the earnings. You see that obviously there is a increasing, okay, pattern as individuals have more education. In 2013, university degree for men, the average was about 3 million won per month. For women, it's about 2 million won, or a bit more than 2 million won per month. Okay? So if you have only high school, that is only, let's say 1.5, and it's the 2.5 something. Okay? So you see the clear linkage between earnings and education. And this positive relationship between earnings and education is so strong that you will see this relationship in almost any labor market, in almost any time. Okay? This is one of, I mean, this relationship between earnings and education is one of the strongest relationship you can ever see in the labor market statistics. So it doesn't matter what country you pick. It doesn't matter what time you pick. You will see clear positive relationship between education and earnings. I think it is still true even if you go to 1,000 years ago. It's still probably the same. Okay. So that's why labor economists pay attention to human capital. Okay? The earnings, labor market performance, all closely related with education, and we call them human capital. And so the theory will try to explain, for example, why this education and earnings are so strongly positively correlated. And first model that we will see is the human capital. And to see the human capital, I will just briefly remind you of present value, the concept of present value, okay, because we need it. I'm pretty sure that most of you are already familiar with the present value, so I'm not going to spend much time. But let's see. For example, what we mean by present value. So present value is the value of some let's say some income that will happen in the future. Okay? So for example, like earning $100, having $100 today, and having $100 1 year later, okay? Nominally they are the same $100, okay? But the value is different. People, think they have two different values. How do we know? Okay, let's say I have $100. I can give you right now, or I can give you 1 year later. Which one would you want? Right now or 1 year later? Right now. Shouldn't it? It doesn't matter because they're the same $100. If you ask anybody, if you ask your 5-year-old cousin, okay, or nephew or niece or whoever, okay, he or she will tell you that I want it right now, right? Probably, I think no kid will say that, oh, I will wait for a year, okay, or it doesn't matter, okay. They will say that I want it right now, okay. Why? Because their values are different, right? Nominally, it looks the same, but their values are different. We have learned it actually in economics class. We have learned it over and over. Okay, so for most people, what you can see is that they like the money right now. It means what? $100 a year later obviously has the smaller value than $100 today. Okay, and we call basically we use a term discounting. So money in the future is discounted. Okay, and how do we discount it? So that's what we use present value. Okay, so how do we do it? Because let's assume that interest rate per year is R. Okay, let's say 10% or 5% or whatever. Actually, we will use mostly discount rate instead of interest rate, but let's call interest rate for now. Okay, interest rate is, let's say, R, like 5%, let's say. So using R, we can say that $100 today will be a year later not $100. It will be $100 times 1 plus R, like a 5% interest. So we will have $5 more 1 year later. If you put it into a bank, now the interest rate is so low. I think now it's like 1%, around 1%, but still, okay? You will have $1 a year later. It's better than nothing. Okay? So anyway, let's use 5%. So you will have $5 more. Okay? So $100 today will be different. It will have different value next year. Actually, have a bigger value. So we can just flip it, and we can say that $100 next year is equivalent to $100 divided by 1 plus R, right? Because if you put $100 divided by 1 plus R into bank, and then 1 year later you will get exactly $100 after adding your interest. Okay? So if it's 5%, so $100 divided by 1.05 will give you $100 next year. And this one is basically discounting. So $100 next year is present value of $100 divided by 1 plus R. And not only 1 year, we can use like multiple years. $100 n years later is equivalent to $100 divided by 1 plus R to nth power. Because if you think about it, if you put $100 today, 1 year later, it's going to be $100 times 1 plus R. You just keep the money in your account. Another year later, it's $100 times 1 plus R squared. Okay? So you do that, and then you just use the logic inversely. So $100 n years later is just $100 divided by 1 plus R to nth power. Okay? So this is the present value of this money. So present value of X dollars n years later, which is X divided by 1 plus R to nth power. So that is the concept of present value. Okay. Okay, so discount rate are, when we say the discount rate, interest rate at this time, we use, in a sense, like a bank discount, bank interest rate. Okay, but this present value or discounting the future value of your income doesn't have to be identical across people. Okay, let's say, as I said, if I give you, let's say, $100 1 year later, okay, people will, in a way, the mental calculation have present values of that money. Okay, it doesn't have to be the same. They don't have to use interest rate. I mean, I will give you an extreme example. Let's say, think of a person who's really sick, who's very ill. So there is a high probability of this person dying within a year. Okay? And for this person, what's the value of, let's say, $1 million 1 year later? Okay? It's likely to be very, very small because this person may not be alive next year. So what's the use of $1 million next year? But for most people, $1 million next year will be a huge value, right? So if you think about it, I mean, this is an extreme example, but obviously you can think of, wow, that must be, an example of having individuals having different discount rate. People have different mental value of the future. Okay, it may depend on such as like their health, their status, their present, their status, and also it can involve, for example, like as I said, the personality. Okay, so impatient person and patient person. When the economists say impatient and patient, it generally means what is the discount rate. If the discount rate is high, then we call that person impatient. Okay? And patient person has low discount rate. Okay? So the future value of the present value of future income is higher for the individuals who have low discount rate. Okay? So patient person generally, okay, tend to wait, okay, more than impatient person. And we call that, patient or present-oriented, impatient, patient or future-oriented, or impatient or present-oriented, or low discount rate or high discount rate. Okay, so present-oriented, impatient, and high discount rate basically, generally they are synonymous, basically the same thing. Patient, future-oriented, low discount rate, the same. Okay, so you should keep in mind that discount rate is likely to be subjective. Probably on average, interest rate. So interest rate is a funny thing. You can think of it as something like probably an average of discount rate of the population. You average them out, you probably converge to an interest rate. That's how we determine interest rate, in a sense. Okay. Anyway, in our case, we use discount rate instead of interest rate. Okay. Okay, now think of a schooling model. Okay, so in this case, schooling, in our model, in this model, schooling is an investment. Okay, that's what we call it, a human capital investment. It's not, you don't go, in our model, you don't go to school for joy of learning. Okay, you probably are very excited about learning economics, and just, the learning economics itself purely gives you very great pleasure, so, you still go to school. But in our case, in this case, no, it's not. Why you learn economics? Because you expect something. You expect something out of this. Not right now, in the future. Okay, and usually it's money. Okay. So that's how we start our schooling model. Okay. So this is an investment. So what we think of is the cost and the return, right? So what is the investment decision? Basically, you look at cost and you look at the return, and is it worth it? Okay, that's the investment decision. Right? Is it worth to spend this amount of money and time to do this? Okay, so basically we just approach the same way the schooling. Okay. So in our model, basically the assumption is that individuals acquire the education level that maximize the present value of net lifetime earnings. So what does education do? Education changes your lifetime income. Okay. So if you have a job after graduating only high school, then you will have a lifetime income. You will have income in your futures. Okay. If you get college degree, okay, then you will have different paths of lifetime income, likely to be higher. If you have, let's say, master's degree, you will also have different paths of your income. Doctoral degree, also different paths. So if you're a rational individual with very good information, okay, you will look at all these different paths and pick the ones that gives you the highest present values. Because it obviously means that having more education will cost you more money and time. Okay? So you have to think of the trade-offs. So to make things really easy, let's think of just one decision, going to college or not. Okay? So think of a person who's going to graduate high school, okay, very soon. So this person should determine whether I should go for college education or not. Okay, okay, so for that person, this person's yearly earnings with the high school diploma, we call it WHS. This is how much this person can earn every year with only high school diploma. And after college, this person will earn WCOR. Okay, but each year, this person should spend money of H dollars. Okay. So this is the yearly cost of college education. Get it? And it's very simple model. Okay, first thing is that let's just look at two paths. One path is just a path of earnings with only high school degree, and the other path is a path of earnings with a college degree. Okay? So we call this present value net lifetime earnings with a high school diploma only, we call PVHS, present value high school, PVHS. PVHS is simple. You earn WHS every year until you retire. We assume this person works for 45 years after finishing high school to make things easy. So this year, this person will earn WHS, and next year, the same WHS. But since it happens next year, this money should be discounted when you think of the present value. So you are determining whether to go to college or not right now. So what matters is the present value. So next year, WHS divided by 1 plus R. And the next year, okay? Get it? 3 years later, WHS divided by 1 plus R squared, and go on and on and on. How about the high school thing? Okay, high school thing is we earn WCOL only after you graduate. Which means if we attend the college for 4 years, each year you paid H. Okay, so you have actually negative earnings for the first 4 years. Okay? So in this year, minus H. Next year, another minus H. But it should be discounted because it's next year. 1 plus R minus H, 1 plus R squared. Okay, and then after you graduate, you start earning WCOL, but it should be discounted. Okay? So it's very simple. It's very simple idea of present values. Okay. And the decision is pretty simple. If PVCOL is greater than PVHS, should go to college. Okay? After thinking of all the costs, okay, there you go. So, one thing about this number is that the cost incurs right now or in the very near future. your income occurs in the farther future, okay? Only 4 years later. Okay? So if R is high, if discount rate is high, these numbers are likely to be small compared to these numbers. Okay? So the cost happens now and return happens later. Okay? Actually, you can write this type of decision rule in different ways. In this case, we just formalized, we have formula for PV-HS and PV call, and we just compare them. Or you can actually think of this, combining them and think of this type of way. Okay, so this, you can think of, you just combine these two. So what you do is that PVHS, PV call minus PVHS. If it's greater than 0, then you go to school, you go to college. Okay? So if you express these PV call minus PVHS, then you will have this. Okay, so H plus WHS 1 plus R squared minus okay. This part, then you can interpret as the cost part of college education. As you can see, the cost involves the direct cost, the tuition, and the foregone earnings, WHS. Okay. So think of WHS, you can think of WHS as a type of cost, foregone earnings. Okay? Then what is the return? The return is actually so return in this case is the difference, W call minus WHS. So if you use this formula, okay, basically it's the same thing. You can say that if these numbers are greater than 0, then you go to college. Or you can just say that PV call is greater than PVHS. Okay. It's the same thing with just in two different expressions. Okay. In this way, you can see the WHS as the cost concept, like foregone earnings concept, much more clearly. But once you understand it, it doesn't matter how you express it. Okay, questions? Actually, this one is helpful. We will see later. Okay, so we can do a very simple numerical exercise, right? For example, assume that there are only 2 periods. Okay? So if the individual works in both periods, does not attend school, she will earn $20,000 each year for 2 years. Okay? If she attends school in the first period, paying $5,000, so no work, only paying $5,000, and works in the second period, she will earn $48,000, much more than $20,000. And if the discount rate is 5% a year, should she attend the school? How do you calculate it? Okay. You need to calculate 2 present values, right? So what is the first present value? Present value, I say no school. How do you calculate it? It should be this year 20,000. Next year 20,000 by 1.05, right? So that's the present value of no school. Okay? And present value of school is what? This year? Minus 5,000. Next year? 48,000 by 0.05. Should she go to school or not? Calculate it. Going to school? Why? What you need is numbers, right? What is a number? What is the value of this? You need to get numbers. Actually, you never know. So it's not. Oh, okay. Go to school or not? Go to school, right? By very little difference. Only about $1,700. Okay. So this is a simple calculation of using the concept of present value. If you look at our textbook problem 6-1, it's very similar questions. A little more complicated, but 6-1 gives you another exercise. So you should try it. 6-1. Using Excel is quite useful, actually. Okay, I actually calculated here. Okay, now using the theory, let's make some predictions. First thing is that the discount rate will affect the level of education the individual gets. How? If the discount rate is high, then this individual less likely to get more education. So education and discount rate is likely to have negative relationship. Okay? So higher discount rate, usually it means what? They put less value on the future income. So this person is less likely to invest. Okay? More likely to spend money right away. So higher discount rate usually means lower education level, and low discount rate, everything else equal, usually means higher education level. Okay. So in our example, for example, if we change discount rate, if we increase it, we use 0.05, but if we, let's say, use 0.07, okay, then still 0.08. Wow. 0.1. Oh, still. 1, 2. Oh, same. Wow. That's surprising. 0.13. Okay? 0.12 is kind of threshold. Okay? So, you see, as you increase the discount rate, then less likely to go to university. Okay, so that's one thing. So that's important. Another, most students will be young. That's what the model predicts. It can even predict your age. Isn't it amazing? Okay. It can tell that you're going to be young. Why? How come this model tells you students must be young? How come? Why is age important in your education decisions? More time to live. So that what it means what? More time, more years to get the return out of your education. Think about it. Let's say you are 50 years old, okay? And after going college, you know that I will work for only 5 years, okay? Then people will seriously think, is it really worth it? But if you are, let's say, 18, right? Then you can get a job after your graduation for 20, 30 years. Obviously that, it looks worth it, right? Why? Because you get the return for 20, 30 years. You get the return only for 5 years, okay? With the same cost. Okay, so obviously there is no question that you should go to school as soon as possible. Okay, if the effects are the same, you should go to school as soon as possible. Okay, makes sense. So that's why all your friends are young. Okay, if it's not the case, you should have very old friends as well. But usually it's not the case. So this one, interesting implication. And you can also explain why most people generally try to finish school, okay, and then go to work. Okay. Actually, this is an interesting question. Why people don't just alternate work and school? Why just people don't just work for 2 to 3 years after high school and then go to school, right? It's a quite possible way of doing education, but usually people choose to go through education, as much as possible, as soon as possible. Why do they do that? Because it makes sense. If you get the return, you should do the education as soon as possible. Do not interrupt your study. Okay? So it's a simple economic reasoning that people tend to bunch their schooling in the early years of their life. Okay? And you start schooling as soon as possible. Okay. Third is obvious one. Individuals will seek higher level of education if the wage differential by education increases. Obviously, if you look at this formulation, the net return of college education it comes from basically the wage differential between college wage and high school wage. If it's greater, it obviously means that the return will be much higher. If it's smaller, return is smaller. Right? So this wage differential is a very important value. Okay? So if the wage differential by education gets greater and greater, people tend to go to school more. If that wage differential gets smaller, then people are less likely to go to school. Okay? So if you look at statistics, actually you can clearly see this. Interesting thing about the Korean labor market is that, as you saw, the Korean labor market, right, we have like in 15 years, the percentage of college graduates have doubled. Okay, why? Why is it doubled? Actually, there must be some return out of there must be a greater return of going to college. Okay, that's why people just go to college more and more, right? Actually, it doesn't make sense from economic point of view. If, let's say, there is not much of return from college education, people still go to school and just the percentage of college education doubled, it shouldn't make any sense. Okay. So actually interesting about Korean labor market is that over the 15-year period, actually, not only the percentage of college graduates has increased, but also college high school wage differential has increased as well. Okay. So now it makes sense because college high school differential has become larger and larger, and people just perceive the greater return to college education. So they tend to go to school, tend to go to college more and more. But actually, recently, since like 2008, 2009, actually the wage differential gets small. It's becoming smaller actually, not by much, but there is a tendency of that wage differential gets smaller. Okay? And probably it's not a coincidence that the percentage of high school graduates going to college, it's getting smaller. It's not by much, but it's getting smaller. So there is some linkage between wage differential and the percentage of people going to college. I think my personal thinking is that now we are just reached to a point where that supply of college graduates is exceeding the demand for college graduates. We are probably reached at this point. So I think wage differential probably will go down even further. Probably it's a bad news for you guys. Okay. but I think there is an increased pressure of supply side pressure on labor market for college graduates. There is some report saying that now the initial salaries for college graduates in Korean labor market is becoming smaller. It's lower than last year. Okay, so it's a supply demand, simple supply demand framework. And now that probably like after from late 1990s to late 2000, supply of college graduates has increased, but demand for college graduates has increased actually even further. So actually the relative wage for college graduates has increased because demand exceeded the supply change. But now it seems like a supply change, at last followed. At last, took up the shift in the demand. So probably it's not going to increase much now. Okay, so far what we have learned is the choice between two education levels. We'll just generalize it to many education levels. Okay, how do we generalize it? To generalize it, we think of this graph. We call it wage schooling locus. Wage schooling locus is just the relationship between the years of schooling and the wages this person expects. Okay, so each person has wage schooling locus. So for this particular person, for 12 years, each year this person, let's say, earns $20,000. For 13 years of education, $23,000, and on and on and on. Okay, so you just connect all those points, then you have wage schooling locus. Okay. This wage schooling locus has upward sloping curve, which means that more education generally involves higher earnings. And the slope, okay, the slope is the increase in earnings associated with additional years of education. So you can say the marginal rate of return to education. You have one more year of education, then by how much your earnings will go up. That's the slope. Right. You can think of this actually vertical axis as lifetime earnings. Here the numbers are very small, but lifetime earnings is much more appropriate way of thinking it. The last one is the wage schooling locus is generally concave. So diminishing returns to education, which means that if you have no education at all, then you have primary education. The return to primary education is very high. And return to middle school education compared to when you have primary education, it gets a little smaller. So a higher education level will give you higher income, but at a decreasing rate. So marginal rate of return is decreasing. For example, you have 4-year education. Let's say you have one more year of education in college. The additional year will not give you much additional money. Okay? So those kind of way of thinking it. Okay, so marginal rate of return is decreasing. So we can just write a marginal rate of return curve. And in this diagram, what it shows is that vertical axis is rate of discount. And actually the two things actually together, we can say rate of discount and marginal rate of return. And marginal rate, you have to draw a marginal rate of return curve, and then if for a particular individual who has, let's say, discount rate R, okay, what is the optimal education level for this person? We can show that this person's optimal education level should be the point where the R, the discount rate, is equal to that person's marginal rate of return to education, MRR. Okay. How can you show that? Okay. Give me an example. Okay. Present value of lifetime income with, let's say, 10 years of education is, let's say, X dollars. Okay. And if this person has one more year of education, then this person's income will be 1 plus rho times x. So rho is the marginal rate of return, obviously. Okay? So rho is the marginal rate of return. So x years with 10 years of education, 11 years with 11 years, this person's income going to be just 1 plus r times rho times x. So MRR is rho. So now this person will attend school for 1 more year if having 1 more of a year education gives greater income than x. Okay. Now having 1 more of a year education gives 1 plus rho times x. But it happens 1 year later because you have to wait until 1 year. So you have to discount it by 1 plus r. This discounted present value of 11 years of education is greater than 10 years of education, the discount value of income at 10 years education, only when rho is greater than r. What it means? What it means is if the MRR is greater than the discount rate, it's worth having 1 more year of education. Okay? If MRR is, let's say, 5%, discount rate is 4%, it makes sense to have 1 more year of education. Because even after discounting it, you will have additional income. But once rho is smaller than r, then it's not worth having 1 more year of education. So what is optimal? Optimal is the same. Okay? So you can say that's the same point S star. If there is another individual who has the same wage schooling locus, MRR, okay, so same wage schooling locus means MRR is the same, but higher discount rate, then you can clearly see that this person's optimal schooling level is lower than this individual. So higher discount rate, lower education level. Okay? You can see the relationship in here. Questions? Okay. Now, think of the wage schooling locus. This wage schooling locus is not observable. What we mean by not observable is that each individual has wage schooling locus. So that means for you, if you have attended, let's say, only high school, you will have certain path of income. And after college graduate, you will have certain path of income. So you will have this wage schooling locus. But for a person, the education level choice is only one kind in life, right? You cannot go back to high school only at this point, right? You already have some college. So if you drop out the university right now, your income gonna follow the wage at a specific point, 1 point in your wage schooling locus, right? So which means that we cannot actually see the individual's wage schooling locus. What we see is only 1 point. Okay? We see only 1 point for each person. Okay? You get it? Only 1 point. Now, from the policymaker's point of view, wage schooling locus is quite important. Why? Because if the wage schooling locus is actually very flat means education does not give much additional income to this person. Why? Probably it's from human capital point of view, it's because the schooling does not give much additional human capital. So the value of investment is very low. If it's very steep, then value of education is very high. So if you're a policymaker, from the, let's say, policymaker's point of view, you're thinking of, let's say, some policy that will affect, let's say, education level. Let's say you want to spend a bunch of money giving scholarships to high school graduates to encourage them to go to college. Okay? Should we do that or not? One thing is we should think of is that what is the opportunity cost of doing it? The opportunity cost is probably that you probably will have less money for other things. you probably can build a better road, better road or better airport, or you probably finance something else, some other social programs. So you have to make a decision. The best way of making a decision is to know what is the return out of this college education. Is it high or is it low? Okay. But the problem in this decision is that we actually cannot see the real wage schooling locus. What we see is only the 1 point for each person. We try to connect. Actually, we can connect them. For example, we have high school graduates. This person has this point, and the other person has a college graduate. Okay, that point. So we can just connect all the points. Then it seems like it will give us the wage schooling locus, but we will show today, and not today, next class, that it's not going to work. Okay, it's not going to work. So we'll discuss why it's not going to work, but there is this case that it actually works. When under one case it actually works, connecting the points. How? Let's assume every person have the same wage schooling locus. Okay, so identical wage schooling locus. What's difference is that these persons have only the discount rate is different. So that means wage schooling locus gives this MRR curve, and each person has different discount rate. So what we see is that on the same MRR line, this person will just choose different points. So that means what? We just connect them, then we can just use all these points to connect all these points, and then we just get the wage schooling locus. Okay? So if we know that individuals have different discount rate, and that is the only reason why people have different education level, then you can actually draw a wage schooling locus. Okay? Because what we know is that, okay, we have only 1 point, but this point is chosen only because the discount rate is different. So for this person has 16 years of education, okay, the 60 years of education, and we have certain amount of money, okay, we can see that, okay, that's for this. And for this person has 12 years of education, and the same curve, just different discount rate. So 12 years, and for this person earns this amount of money. And we have enough number of people, then we can just connect them. We have all these points that are required to make a wage schooling locus. Okay. Probably it's not clear to you right now, but next class, then I will show you the case where this thing does not work. Then you can compare them. You will see how clearly that this makes all the differences. Okay, okay, that's it for today.